All right, so last class we talked about momentum and impulse. And let me emphasize that momentum is the mass times velocity. Obviously, the faster it goes, the more momentum it has, and then the bigger mass, the more momentum it has. Okay? How and then impulse is similar to momentum, but it's the change in momentum. Well, in last class, we used the example of a batted ball to discuss the impulse and momentum change that occurred with the ball. So, we have the ping pong ball and we have bowling ball. It's if they have the same velocity, the bowling ball is harder to stop, right? So, at that time, we only talk about or compare one thing to another. We did not consider what happened when two things collide. Okay? So, according to Newton's third law, there are action on one object, there must be a reaction on the other object. So when you are hitting a ball with a bat, the bat exerted a force on the ball. The ball also exerted an equal and opposite force on the bat. Since the time of the collision between bat and ball is the same time for those two, then we have equal forces, but in opposite direction exert for equal times on the ball and bat. That means that the impulse exerted on the bat is equal and opposite to the impulse on the ball. And that also means that there was a change in momentum of the bat that was equal and opposite to the change in momentum of the ball. So basically, what it was telling you is that when you hit the ball with a bat, right? Of course, there are reaction. There are opposite forces, but equal, right? So remember, our change in momentum, which is impulse, is F times time, right? So if we have opposite force exerting on both, then we're going to have change in momentum, which is also equal but opposite direction on both. That's why when you hit the ball's coming towards you. When you hit it, the ball is going away from you. And when you use the bat to hit the bat is swinging forward, but you can feel the kickback, right? So that is the change in momentum. That's impulse. So the change in momentum of the ball is quite obvious because it changed direction and flies off at greater speed. However, the change in momentum of the bat is not obvious at all because the bat is heavier. So due to our momentum equal mv, right? So if your momentum is equivalent to each other or equal to each other, the more mass will result in less velocity. Okay. So that was talking about bat and ball. Let's think about something else. Consider another system, that of two ice skaters. If we have one of the ice skaters exert a force on the other skater, the force is called an internal force because both the object exerting the force and the object receiving the force are inside the system. Here, we're talking about a closed system. So in a closed system, such as this, momentum is always conserved. The total final momentum always equal to the total initial momentum in a closed system. So if you remember anything from chemistry, we learned the conservation of matter, right? Or you heard me talk about energy cannot be created or destroyed all the time because we are talking about the energy, all those things in a closed system. So energy on Earth is a closed system. So, circle of life, right? You probably stay home and watching rerun of Simba and Lion King 1, 2, 3, like I do. So anything on Earth in a closed system is conserved, basically. So here, if we only think those two skaters are together, okay, consider as a closed system, whatever they have, the momentum they have initially will be the same momentum they have after they collide, okay? So here, it also talk about conservatively, if we define the system to contain just one ice skater, putting the other skater outside the system, then this is not a closed system. So, so the energy that inside the closed system and outside the closed system cannot compare to each other. If one skater pushes the other, the force is an external force because the receiver of the force is outside the system. So momentum is not guaranteed to be conserved unless the system is closed. Basically, remember, they only conserve when it's closed. So in a closed system, momentum is always conserved. There's another example. If we consider two billiard balls colliding on a billiard table and ignore friction. Okay, so friction is not in that system. So we only consider the force and the momentum here, right? So those two balls are together in a closed system. So the momentum of ball A before the collision, which is the initial momentum, plus the initial momentum of ball B will be equal to the momentum of A and B after they collide. This is what we call the law of conservation of momentum. You can take a look at this video. The rest is just calculation. So today we'll only talk about the conservation of momentum. Okay? Basically, what you have before collision is equal to what you have after collision. So let's take a look at example 1. So example 1, it says a ball A has 2 kilograms, is moving due west of 2 meters per second. And ball B has 4 kilogram is moving west also with a velocity of 1 meter per second, right? Ball A overtake ball B and collide with it from behind. After the collision, ball A is moving westward with a velocity of 1 meter per second. What is the velocity of ball B? Very straightforward. You have the mass and velocity before and after the collision, right? All you have to do is set up your equation. Right? Set up your equation. And then each momentum, you write it out like that. And then you put the number. You find your velocity of ball B after collision. And the second question is the same idea. Okay? So what I want you to do is during this class, after you watch this video, is to write down all the highlights as your note on your notebook. Do the questions here, 7 questions in review, and to test and clarify your understanding. Then you go back to the lecture and you do your exit ticket, your homework, and there's also a bumping car challenge. It's just a practice question that I want to do during the class. So next class, we're going to have a quiz, not on this matter, but on the last one, just the momentum and impulse. Okay? We're going to have the quiz on this, conservation of momentum, the class after. Good luck!